Welcome to this explainer. Have you ever just stopped, really stopped, and looked at the absolute magic sitting right there on your desk? Or maybe the one you're holding in your hand right now? It's wild to think about. Right at this very second, your device is processing billions, literally billions, of microscopic calculations just to bring this explainer to you. Today, you and I are going to step into a completely different role. We are becoming digital anatomists. We're going to dissect the computer. It's a machine that honestly feels almost supernatural in what it can do, yet it is built on entirely logical, completely understandable foundations. We are going to strip away all that intimidating, complex jargon. We're looking at the raw, incredible blueprint that makes our entire modern era possible. Okay, are you ready? Let's dive right into this.
It's a pretty profound question, isn't it? Just think about it for a second. How does a silent, cold box made essentially of silicon, some metal, and plastic manage global financial markets? How does it render those breathtaking, hyper-realistic video game worlds we get lost in? How does it connect billions of people across the globe in a fraction of a second? Well, we are going to plunge straight into this mystery today. By the end of this explainer, I make you a promise. We will break down this incredibly complex machine into its two fundamental halves. We're going to look at its body and its mind. And we're going to do it so clearly and so simply that honestly, a primary school student could grasp the sheer genius behind it.
To truly understand any computer, we absolutely must start with the fundamental dichotomy of technology. It's the ultimate balancing act. On one side, we have hardware. You can think of this as the physical body of the machine. It is tangible. It's everything you can physically touch, pick up, drop, or, heaven forbid, accidentally spill your morning coffee on. Then, on the completely opposite side, we have software. This is the digital mind. It is the intangible, invisible soul of the machine. Software is pure logic. It's a vast, complex collection of language codes and instructions. Now think about us humans. Just like a physical human body absolutely needs a mind to have any sort of purpose, direction, or life, computer hardware is utterly, completely useless without software telling it exactly what to do. So where do we begin this dissection? Let's start by looking at the physical foundations.
Section 1. Hardware. The physical body. Let's get our lab coats on and look under the hood to see exactly what makes this machine tick. When most of us hear the word computer, this is exactly what pops into our heads, right? The classic, traditional desktop setup. You've got the tower sitting there, the glowing monitor, the clicking keyboard, the mouse, and maybe a pair of speakers. This setup perfectly grounds our concept of hardware in physical reality. You can reach out and touch all of it. But here is the absolute crucial point. Everything you normally interact with, the shiny screen you're staring at, the keys you're typing on, all of it is completely 100% useless without the internal nervous system that is hidden securely away inside that metal tower. That box is where the actual magic happens.
Inside that metal box, shielded from the outside world, lie the 5 vital internal organs. A computer absolutely needs these 5 elements to wake up and operate. Think of them exactly like the biological organs in our own bodies. First, we have the motherboard, which is the grand skeleton and nervous system tying everything together. Then there's the CPU, or the processor. This is the calculating brain doing all the heavy thinking. Next up is RAM. This is the machine's incredibly fast but short-term memory. It remembers what you're doing right now. Then we have storage, the long-term memory vault where all your files, documents, and photos live permanently. And finally, the GPU, or graphics card. You can think of this as the machine's visual imagination, constantly translating complex math into the beautiful, rich images you see on your screen. Here's the crazy part. Take any single one of these 5 organs away, and the entire system instantly fails.
Let's look a little closer at the absolute foundation of it all, the motherboard. It is the central circuit board of the entire operation. Now, to be clear, the motherboard doesn't actually process any data itself, and it definitely doesn't store your family vacation photos. Instead, its job is arguably more important. It is a grand, incredibly complex highway system. It acts as the central nervous system where data travels back and forth at literally near the speed of light. It connects the brain, that's the CPU, to the memory, to the GPU, to the rest of the body. Without the motherboard, none of these brilliant, expensive components can speak a single word to each other. They'd just be isolated islands. But wait, this raises a genuinely fascinating question. If all of this makes up the internal body, locked inside a dark box, how on earth does this machine sense the outside world?
Section 2. Peripherals are digital senses. Let's step outside that metal tower for a moment and see how this machine interacts with us. So, how does this cold, calculating machine actually communicate with you, a living, breathing, unpredictable human being? Well, it needs digital senses. We call these peripherals, and they are literally the senses and the voice of the computer.
We divide them into three incredibly simple categories. First, we have input devices. Think of your keyboard, your mouse, or a microphone. This is how data flows into the machine. It is quite literally how the computer hears and feels your commands. Next, we have output devices. This is your monitor or your speakers. This is how the machine expresses itself back to you, translating all that internal invisible data into sights and sounds you can understand. And finally, we have mixed devices. The perfect example is a touchscreen on a tablet or phone. It acts as both input and output simultaneously. You touch it to give commands, and it flashes images back at you.
Let's take the humble, everyday inkjet printer, for example. It is the absolute classic output device. When you really think about what a printer does, it's almost like a magic trick. It takes entirely invisible, abstract, digital information, just millions of microscopic zeros and ones flying around the motherboard at the speed of light, and it magically reproduces that data into our physical reality. It meticulously places drops of ink onto paper so that you can hold a photograph or a document right there in your hand. It's bringing the digital into the physical. But listen, having digital senses in a highly complex physical body is completely useless without an intelligence to command them. And that brings us to the true ghost in the machine.
Section 3. Software, the digital mind. We've built an incredible body, but a body without a mind is dead. Let's reveal the invisible force that runs the show. Okay, so the absolutely crucial point here is understanding exactly what software actually is. By definition, it is the grouping of programs and language codes that are strictly necessary to give orders. It is pure, structured, mathematical logic. Imagine for a second, going out and buying the most expensive, top-of-the-line, incredibly powerful computer hardware in the world. You assemble it perfectly. Without software, that machine is literally nothing more than a very, very expensive paperweight sitting on your desk. It does nothing. The software is the intelligence that formulates the exact, step-by-step instructions the hardware must follow. It is the ultimate translator, taking human intent, what you want to do, and turning it into electrical signals the machine can execute.
And the way this intelligence works isn't just chaos. There's an exact, highly organized chain of command. It's a strict hierarchy. Think of it like a corporate ladder. At the very top, there is you, the user, the boss. You interact directly with the application software. Let's say you open up a web browser. That application doesn't talk directly to the metal parts. Instead, it speaks down to the system software, your operating system. Finally, the operating system reaches down into the dark and commands the actual hardware, telling the physical processor to calculate and the monitor exactly which pixels to light up. It is a beautiful, entirely invisible cascade of communication, happening thousands upon thousands of times every single second you use your device.
Section 4. Systems and Applications. Let's look at how this digital mind organizes itself to serve you.
Because here's the thing. The digital mind isn't just one big messy blob of code. It is fiercely and cleanly divided into two distinct layers, and they perform very, very different jobs. On one side, we have system software. This includes your operating system, think Windows, Mac OS, or Linux, alongside essential drivers and background tools. These are the absolute unsung heroes. They are the background managers that keep the machine alive, breathing, and functioning properly. You rarely interact with them directly. Then on the other side, we have application software. These are the everyday tools you actually launch to get your work done or to have fun. We're talking about your word processors, your internet browsers, and your video games. Think of it this way. System software exists entirely to serve the hardware, while application software exists entirely to serve you.
We really need to give the operating system the massive respect it deserves. It is working incredibly hard. The moment you press the power button, it boots the computer to life. It creates the entire visual environment, the desktop, the folders, the mouse pointer that you click around in. But deeper than that, it acts as the ultimate hyper-fast traffic cop. It relentlessly manages the CPU's processes, deciding exactly what math gets calculated first. It meticulously handles the short-term memory, ensuring that your web browser doesn't accidentally crash into your video game, and it administers every single input and output resource. It is performing this incredible rapid-fire multitasking millions of times a second behind the scenes, all so you can sit back and watch a video without a single stutter. It's mind-blowing. And here is where the story changes completely, because now that you know how the mind and body work, you can build one.
Section 5. Building your own PC. Let's take all this knowledge and turn it into a practical, real-world blueprint. I absolutely love this quote from our source material today. It says, although building a PC is as easy as putting together a Lego set, you should know about the building blocks before starting. I love it because it perfectly shatters this massive, intimidating illusion. So many people think that PC building is some kind of dark, mysterious art reserved only for elite tech geniuses. But it's not. It really is just snapping compatible modular blocks together until you have a working machine. However, to do it right and to not waste your hard-earned money, you absolutely need a practical blueprint. You need to know exactly how to balance your budget.
So let me reveal the ultimate secret formula for a perfectly balanced machine. If you want to avoid frustrating bottlenecks where one slow part holds back all your fast parts, your budget needs to be distributed very strategically. The foundation, your motherboard, should take up about 10 to 15% of your total budget. Your RAM, your storage vault, the power supply, and the metal case itself will share the remaining percentage. But I want you to look at that massive dominant chunk of the pie dedicated entirely to the CPU and the GPU.
50 to 65%. That right there is the absolute golden rule of PC building. You must dedicate the lion's share, over half of your entire budget, strictly to the computer's brain, the CPU, and its visual imagination, the GPU. Why? Because these two components alone practically dictate the raw processing power and the visual fidelity of your entire machine. If you skimp on these to buy a super fancy case or an excessive amount of memory, no amount of pretty lights will save your computer's performance. It will be sluggish. Investing heavily in the CPU and GPU is the critical, non-negotiable secret to guaranteeing a powerful, high-performance experience that will last you for years.
We have journeyed through the perfect, almost magical symbiosis of hardware and software today. We've opened up the box, we've looked at the organs, and we've seen how cold physical circuits and invisible logic codes seamlessly combine to create literally the most powerful, versatile tool ever invented by humanity. And the best part? You now hold the blueprint. The mystery is gone. So I want to leave you with this final provocative thought. Now that you truly understand the anatomy of this digital entity from the inside out, what incredible machine are you going to build to shape your own world? Thank you so much for joining me on this explainer. Keep wondering, keep building, and I absolutely cannot wait to explore our next fascinating topic with you. See you next time.